So this time I'm talking about Venn diagrams again, but this time I want to look at the intersection. Now the intersection, you've seen the word intersection before. Two streets and they meet in the middle. So cars are driving this way, cars are driving this way. The intersection is the bit where they either stop and give way or they crash into each other. So that's what we mean by the word intersection. Now you can probably guess, looking at your Venn diagram, where the intersection is. It's this part in here, where the number 7 is. Now, the intersection, in terms of the maths we're going to be doing, can also be approximated by a very simple word. And. Okay? So, these 7 people belong to set A and set B. Pretty straightforward. Now we have a symbol for the intersection. The symbol looks like this, an upside down U. And if we're going to put that into a question, which I think we should, we can say that the probability of A intersection B. Now remember, that means intersection or and. So the probability that if you pick a student, there's 28 students in this class, if you pick a student at random from this class, the probability that they play both rugby and cricket is going to be equal to probability here. 7 over the total, 28. Very, very straightforward, but it's important for us to learn a couple of key bits. The intersection, what is it? It's that bit there. The intersection can also be used, phrased using the term and. The probability of A and B is here. We use this symbol, probability of A intersection B, or A and B. Intersection is more fancy. And the intersection is very, very simply, or the probability of that, very, very simply, this divided by 28. Very straightforward stuff. We're going to look at unions next.